Hello everyone. We will make a preliminary design presentation, which is the first presentation of this semester. Let's start with the first step now. General information about the building. In this project, our structure is a student dormitory. The structure is symmetrical and designed as a boys' dormitory on one side and a girls' dormitory on the other. This structure consists of two separate sections. The structure is modeled as two buildings, and there is a 15 centimeter dilatation gap in between each other. According to the architectural drawings, there is the main hall in the top part and the dormitory part in the bottom part. Main hall sections consist of two floors. On the first floor, there is an entrance hall, meeting room, secretarial, etc. And the second floor, a library, common areas, etc. The dormitory part consists of 5 floors. It is designed as 5 floors symmetrically identical to each other. In total, there are 50 rooms. Location is Erzincan from Turkey. Second step is design criteria, structural system. In the AutoCAD file, which is the architect's draw about dormitory drawings, we analyze the project data and structure. Before the structural system in SAP 2000, we closed many unnecessary layers in AutoCAD for analysis easily. The first version of AutoCAD data might be confusing. As a result of the investigations, we started to find out dimensions and distance between walls, beams, shear walls. After calculating the distances, we started to draw in SAP 2000 grid data. Here we can see our grid data in the following 3 photos. These snapshots from SAP 2000, this is our structural system of main hall in SAP 2000, end of the grid data version. This is again the dormitory part, end of the grid data version. 2.2 material selection. Before the draw frames, columns or beams, we must define materials. First, we started from concrete. We can see from this photo. We define our steel. We can see from this photo again. S420. Design codes. These are the regulation and formulas that we use. Loads and combinations. This is the general formula, 1.4G plus 1.6Q. For the preliminary design, the earthquake load is not performed. Therefore, there is only one load combination. Slab design for main hall. We started to calculate slab values for each area. After calculating all slabs for each area, we decided to make slab thickness 27 centimeter. On the submodel, we should mesh the areas for more accurate results. In the slabs, to determine the slab reinforcements, we checked the TS 500 sections, 11.4.5. These are the snapshots from Excel. This is the main hall, types of slabs. For the moment values of slabs for main hall, as you can see from Excel. Reinforcement design of slabs for main hall again. Mesh slabs of main hall on SAP 2000 photos. Slab design for dormitory ports. The same calculations and regulations. After calculating all slabs for each area, we decided to take slab thickness is 26 centimeters. This is the example of slab D20. Types of slabs for dormitory parts. The moment values of slabs for dormitory part again. Reinforcement design of slabs for dormitory part. Mesh slabs of dormitory part on SUB 2000. Next step is beam design for main hall. Our thickness is 27 millimeters. Our beam is B30 cross 60 as we can see from the photo. For the beam 29 calculations as the following steps. This is the calculations for guide. Cross-sectional view of beams on the K-axis. Section AA cross-sectional view of beam B29. Beam design for dormitory parts. Our thickness is 26 millimeters. Our beam is B30 cross 70 as we can see from the photo. For the beam 58 calculations as the following steps. This is the calculations according to the TS500. Cross-sectional view of the beam on the axis 3. Section BB, cross-sectional view of beam B59. Column design for main hall. In the beam, we must calculate areas. First, we must calculate the tributary area. As we can see from the photo of AutoCAD. This is for C1. These are the calculations and steps. In the SUB 2000, we defined one type column. We defined C60 cross 60. We can see the column properties from this photo. Main hall column size. As a result, all columns at the main hall satisfy the minimum column area. All of these are okay. Column design for dormitory parts. In the beam design, we must calculate areas. First, we must calculate the tributary area. This is the snapshot again from AutoCAD. Example is this column. For C28, these are the calculations and steps. In SUB 2000, we defined 5 types of columns. These are the types. We can see the columns properties from this photo. All of these are here. Dormitory part column size. After all calculations, some columns are not satisfying the minimum column dimensions. These column dimensions will be enlarged for the final design. These are the, as you can see, that they are not okay. Preliminary sizing of the foundations for main hall. These calculations have been made for C11. The dimensions of column is 6 cross 6 centimeter. We have been assumed the depth of the mat foundation as 0.5 meter. A punching shear check should be done. These are the calculations again. As you can see, all calculations, it's okay. Preliminary sizing of foundation for dormitory parts. This is the again the same. These calculations for C15. The dimensions of column is 6 cross 6 centimeter again. A punching shear check should be done. We have been assumed the depth of the mat foundation as a 1.2 meter. These are the calculations. It is okay again.
Reinforced staircase design. In our project, the stair design loads and reinforcement are calculated. Step height and step width is found. After choosing the waist and landing thickness, waist load was found. This value is normal to the inclination and step area also found. The loading is converted to the global Y direction. So the total dead load and design loads are found. These values are area loads. They are converted to the distributed load. Then for the landing and waist portions, the design loads were calculated. After that, design moments were found. For the reinforcement design, the calculations were done according to the cantilever one-way slab conditions from TS 500. Slab width is determined as 1 meter. For the calculations, the design moment of waist portion was used. A is calculated, then according to this result, AS calculation is found. For the codes, raw minimum for the main reinforcing for S420 greater than 0.002 and main reinforcement spacing is less than 200 millimeter and 1.5 times H. After these results, we found the maximum main reinforcement spacing is 150 millimeter. Distribution reinforcement orthogonal to main is minimum 1/5 of main reinforcement and the maximum spacing less than 300 millimeter. So after this calculations, phi 8 over 25 centimeter is chosen.
The changes have been made. First one, due to the high rigidity, we decided to remove the T-shaped shear walls. At the same time, living area and usability have been made highly efficient. This is the before. This is the T-shaped shear wall. After that, we change it. Second one, the elevator shaft should be surrounded by a shear wall, but it is not. It was not the original drawings. We revised the rear and the right side as shear wall. This is the before, and we add the shear walls. The third one, as we mentioned in the first point, we decided to remove the shear walls due to the high rigidity because when the structure was rigid, the formation was less. Before, everywhere is shear wall. After that, we change it columns. Fourth one, according to the original drawings, half of one of the columns passed through the safe security cabin. It is somewhat incomprehensible that this happens. Therefore, we have moved the safe security cabin in the positive Y direction by 25 centimeter to make it tangent to the column, and we shorten dimensions of the column. This shear wall before things, and after that we change it like a column, and we shorten the dimensions. Fifth, since there is a lot of oscillation in the X direction in the dormitory part, we added shear walls symmetrically and at regular intervals in the X direction. Before snapshots, and we change it with shear walls. These are the general weave before and after. for the dormitory part, before and after snapshots from AutoCAD.
And the last part is cost estimation for the main hall. When doing this calculation, the unit price was taken 212 Turkish liras per meter cube for C30 concrete, and unit price of C420 steel was taken 2.47 Turkish liras per kilogram. This is the cost analysis for concrete and cost analysis for reinforcements. The last part is cost estimation for dormitory parts. This is the same price. This is the cost analysis for concrete and cost analysis for the reinforcements. The total cost is 820,880 Turkish liras.